Hi everyone. So we are ready to take some more examples on Z transform. In my previous videos, we have computed Z transform of some of the important sequences. I will simply list down them. We obtained Z transform of unit impulse sequence or Kronecker impulse sequence, and we found that the Z transform of impulse is 1 with ROC entire Z plane. And then we saw Z transform of another sequence. It is an infinite duration sequence, half to the power n un, and its Z transform was 1 upon 1 minus half Z inverse with ROC mod Z greater than half. And then in previous video, you saw that Z transform of the sequence minus half to the power n u of minus n minus 1, it was 1 upon 1 minus half Z inverse with ROC mod Z less than half. That we have done in the previous video. Now today we will take some more example. So let us start with this example. Xn equals half to the power n un plus 2 to the power n u of minus n minus 1. You can see this time the sequence xn is summation of two different sequences. Let it be x1n, let us call it x1n, and let us call this sequence x2n. And now this xn is summation of x1 and x2. And we have to obtain the Z transform of xn. Now, if I try to write out x1n in terms of pieces, or if I express x1n in piecewise representation, then what I can write, x1n is half to the power n for n greater or equal to 0, and it is 0 for n less than 0. Now if I write piecewise representation for x to n, so what I can write, what is x to n? X to n is 2 to the power n for n is for n less than or equal to minus 1, which is also same as n is strictly greater than 0. N is strictly greater than 0 is same as that of n less than or equal to minus 1, and it is 0 for n is strictly greater than 0. So these are the two sequences, and xn is the summation of x1 and x2. Now if you add this x1 and x2, and if you try to express this xn in pieces, if you express xn as a piecewise representation, what you will get, you can see that x1n is non-zero for n greater and equal to 0. Whereas here, this, now this is for, this is here, there is some correction. It is 0 for n greater and equal to 0. So only x1n is non-zero for n greater and equal to 0, whereas x2n is 0. So if you add these two sequences for n greater than and equal to 0, what you will get? You will get this xn is what? It is half to the power n. For what? For what values of n? For n greater and equal to 0. Now, for n is strictly less than 0, x1n is 0, whereas x to n is non-zero. So now if you add these two sequences for n is strictly less than 0 or for n less than or equal to -1, what you will get? You will get 2 to the power n for n less than 0. So now we have, this is what? This is the piecewise, sorry, this is the piecewise representation for what? Xn. So I express it on next page. So now we have what is Xn? Xn is half to the power n for n greater and equal to 0, and it is 2 to the power n for n less than 0. And now we have to obtain Z transform of this sequence. So what would be the Z transform of this sequence? So from the definition of Z transform, Xz is what? It is the summation over n from minus infinity to plus infinity, x of n, z to the power minus n. Now I can split my summation into two parts. See, this is n equals 0. So there are two parts. One part is for n greater than and equal to 0, and other part is what? For n minus 1 to infinity. This is n minus 1 to minus infinity. And this part is from the right hand side part is from n equals to 0 to n equals infinity. So if I split this summation into two parts, one part I write from minus infinity to minus 1, and other part I write from not minus 1 to infinity. It is from 0 to infinity. Now, what is my xn between minus infinity to minus 1? So you can see for n less than 0, the sequence is 2 to the power n. So I shall write it is 2 to the power n multiplied by z to the power minus n. And this summation is what? For n between 0 and infinity, my xn is what? Half to the power n multiplied by now z to the power minus n. So now this time we have two summation, two series. Let's say this is x1 and let's say this is x2. And we work out this x1 and x2 separately. And in fact, we have already worked them out. But for sake of revision, I will work them out again. So what is the first summation? First summation x1z. It was 2 to the power n z to the power minus n. N from minus infinity to minus 1, 2 to the power n z to the power n, which can be written as n running from minus infinity to minus 1, 2 inverse z to the power minus n. And now I make change of variable. Let us say n is minus m, or you can say m is minus n. Then what this summation would be? This summation would be m from plus infinity to plus 1 and 2 inverse z to the power m. In previous video, we have already seen that if we change the limits of summation, there won't be extra negative sign outside the summation, unlike the integration. So I can write this is equal to m from 1 to infinity 2 inverse z to the power m. And if I expand this, I get 2 inverse z plus 2 inverse z squared and so on. And again, this is an infinite GP. And we know that the summation of infinite GP is A0 upon 1 minus R, provided that mod of R is less than 1, where A0 is the first term and R is the common ratio. So what is this summation? It is 2 inverse Z upon 1 minus 2 inverse Z, but this summation is possible when the common ratio 2 minus Z's mod is less than 1. Or in other words, you can say when Z upon mod Z upon 2 is what? Less than 1, which implies mod Z is less than 2. So we have obtained the summation x1, which is corresponding to Z transform of the sequence x1. Now if we try to compute the summation x2, what is summation x2? Summation x2 is half to the power n z to the power minus n. So we find this x2z. x2z is summation from 0 to infinity half to the power n z to the power minus n. And I will not solve it again, we have already done. Its Z transform is what? 1 upon 1 minus, the summation we have already computed. So 1 minus half Z inverse with mod Z greater than half. So this time, this xz is summation of two series. One series is x1 and another series is x2. Now we have seen this x1z, what we have obtained, this x1z is 2 inverse z. It is 2 inverse z upon 1 minus 2 inverse z for mod z greater than 2. And this x2z is what? It is 1 upon 1 minus half z inverse for mod z. Sorry, this is, there is a correction. This is not for mod z greater than 2, but it is for what? It is for mod z less than 2, and this is for mod z greater than half. Now, naturally, this series xz will be converging when both the series are converging simultaneously. If one series x1 converges and x2 doesn't, then xz will not converge. Similarly, if x2 converge and x1 doesn't converge, then also xz will not converge. So for the convergence of xz, it is required that both x1 and x2 are converging simultaneously. Now question comes, when both will converging simultaneously. So the region where both the sequences are converging, in that region only xz would be converging. So we have to find a common region where both this x1 and x2 are converging. So what is that common region? To find that common region, we draw that region in z plane. So let's say this is my z plane. This is real axis and this is my imaginary axis. Now first I draw the ROC for x1, which is mod z less than 2. So what I have to do? I have to draw a circle of radius 2. So this is the circle of radius 2. The radius is 2. And what is the ROC? ROC is the interior of this circle. So interior of this circle would be this. So this is the interior of this circle. And for x2, what is the ROC? Mod z greater than half. So I have to draw a circle with radius half. I draw this is my circle, this is my circle with, let's say, the radius is half. This is the radius half. But what is the ROC? ROC is exterior to this circle. Exterior to this circle means this region, this green region, which I am drawing. I am hatching with green color. Now, which is the region where both colors are appearing simultaneously, red and green? So naturally that region is this annular region, which I mark by blue color. So this is that region, this annular region between half and 2. So we see that XZ will be converging, or X1 and X2 both will simultaneously converging for mod Z greater than half and less than 2, which is this annular region. So what we get? We get, what is the expression of Z transform? It is 2 inverse Z upon 1 minus 2 inverse Z plus 1 upon 1 minus half Z inverse. And what is the ROC? ROC is mod Z greater than half and less than 2. Now one thing, here the expression is in Z, whereas here the expression is in Z inverse. So if you want expression in Z inverse, you divide numerator and denominator by 2 inverse Z. Then what you will get? You will get 1 upon, now 1 upon 2 inverse Z will become what? 2Z inverse minus 1 plus 1 upon 1 minus half Z inverse with mod Z lying between half and 2. So this is, now this expression can be further simplified, but that is trivial. What is important and what is the central point of this example? The central point is that the ROC is what? ROC is a annular ring. Which ring? For mod Z greater than half and mod Z less than 2. Now, if I slightly change this problem, and if I ask what is Z transform of 2 to the power n un plus half to the power n u of minus n minus 1. Now again you can assume this is x1n and this is x2n, and you can find x1z. So can I write this time x1z directly? What it would be? It would be 1 upon 1 minus 2z inverse, and what would be the reason of convergence? Reason of convergence would be mod z greater than 2. And what about x2z? What would be x2z? X2z would be, I am writing minus 1 upon 1 minus half z inverse with mod z less than half. And we know that this xz would be what? x1z plus x2z. Now, what is the ROC for x1z? It is mod z greater than 2. And what is ROC for this? Mod z less than half. Now, since xz is summation of x1 and x2, so xz would be converging only when the x1z and x2z both are converging simultaneously. So what is that region where x1 and x2 both are converging at a time? Now this region is mod z greater than 2. So this is the region exterior to the circle of radius 2, and this is the region which is interior to the circle of radius of half. So if we draw these two regions in z plane, so this is my z plane again. This is the real axis. This is the imaginary axis. Now there are again two circles. One circle is with radius half And what is the ROC for this x2? It is less than half. So less than half means interior to this circle of radius of half. And other region is what? Corresponding to x1z. Other region is what? This is the circle of radius of 2 corresponding to x, corresponding to x1. And what is it? What is the ROC? It is exterior to this circle. So exterior to this circle, this region. Now can you give me the region where both are overlapping? See, there is no such a region. We can't have a region which is less than half, which is common. Means what? Which region we want? We want a region which is what? Greater than 2 and less than half. Common. There is no such a common region which is greater than 2 and less than half. So that region is what? Null set. So there is no such a region. And therefore, what would be the answer for this xn, for this given xn? What is the Z transform? Because there is no such a region where both are converging simultaneously. So Z transform does not exist. The answer is Z transform does not exist for this sequence. For which sequence? This sequence 2 to the power n un plus half u of minus n minus 1. So we have now seen three different infinite duration sequences. Which three different infinite duration sequences we have seen? First we saw half to the power n un, and its Z transform was 1 upon 1 minus half Z inverse with mod Z greater than half. Other sequence we saw minus 2 to the power n u of minus n minus 1. What is Z transform of this? 1 minus 2Z inverse with mod Z less than 2. And another sequence which we saw half to the power n un plus, or okay, 2 to the power n u of minus n minus 1. What is the Z transform of this? It is 1 upon 1 minus half Z inverse minus, because I have not taken minus sign here, therefore minus sign will come here, 1 minus 1 to Z inverse with mod Z greater than half and less than 2. So these are the three different examples which we have worked out. Now what is the conclusion we can make from these three different examples in terms of ROC? Now this sequence is called right-sided sequence, right-sided infinite sequence. This is a left-sided infinite duration sequence, and this is two-sided infinite duration sequence. So let me explain what is meant by right-sided sequence and a left-sided sequence and both-sided sequence. If the sequence is extending in right of some point, let's say that point is n naught. Extending means if the sequence is having non-zero samples for sequence xn is non-zero for n greater and equal to n naught, and it is 0 for n is strictly less than n naught, where n naught could be what? N naught could be positive, negative, or 0. So for example, let's say I draw a sequence un, unit step sequence. You can see that unit step sequence has values 1 in right of, this is now our n naught. So and values are 0 in the left of this n naught. What is n naught here? 0. So this is an example of right-sided sequence. Now, let us take one more example. If it is u of n plus 2, u of n plus 2 will be what? 1 for n greater than minus 2 and 0 for n is strictly less than minus 2. So if I draw this sequence from minus 2 onwards, it is 1 and so on. And it is 0 at minus 3, at minus 4 and so on. So what is n naught this time? N naught is minus 2. Sequence has non-zero values in the right of this n naught, which is minus 2, and sequence has 0 values in the left of this n naught. Therefore this is also a right-sided sequence. And this sequence which we took, half to the power n un, which kind of sequence it is? Naturally, because this is multiplied by un, it is extending in the right side. Extending in right side means what? It is having non-zero samples for n greater or equal to 0. So this n naught is what? In this sequence, n naught is 0. So this is also, this half to the power n un, this is also example of right-sided sequence. Now, if I take example of left-sided sequence, what do you mean by left-sided sequence? If this xn is non-zero for n less than or equal to n naught, and it is 0 for n greater than n naught, then this is called which kind of sequence? Left-sided sequence. So, if you take an example of left-sided sequence, u of minus n minus 1. What was this sequence? This sequence was 1 for n less than or equal to minus 1, and it was 0 for n greater than minus 1. So if you draw this sequence, it is having non-zero values for minus 1, minus 2, minus 3 and so on, and it has 0 values for n0, n1, n2. So what is my n naught this time? N naught is my n naught is minus 1, and you can see the sequence has non-zero values for n naught, for non-zero values for n less than minus 1. So this is example of left-sided sequence. Similarly, if I ask what is this 2 to the power n u of minus n minus 1, this is also an example of left-sided sequence because the sequence has non-zero values in the left of minus 1, including minus 1. Now what about both sided sequence? If xn is non-zero for n naught for n less than or equal to n naught as well as for n greater than n naught. In both the reason, let's say this n naught point is here and sequence is having non-zero values in left and right both of n naught. This is some sequence I have drawn, and this is an infinite duration sequence. Now you can see, let's say this n naught is 1. So now this sequence is having non-zero values in the left of this point n naught and right of this point n naught. Therefore this sequence is both sided sequence. For example, we xn is half to the power n un plus 2 to the power n u of minus n minus 1. Here sequence is having values half to the power n for n greater and equal to 0, and it is having values 2 to the power n for n is strictly less than 0. So if you take n0 as 0, so in left and right of this 0 point, this 0 index, you are having non-zero values. So this is also a both-sided sequence, both-sided infinite duration sequence. And we have worked out Z transform for all these three types: right-sided, left-sided, as well as both sided. Now, what observation we can make from these three different types of sequences Z transform? Now, the first sequence, half to the power n, un, which is a right-sided sequence. For it, Z transform is of the form mod Z greater than something. That something is not important, but what is important, the Z transform is exterior to the some circle. The second sequence, minus 2 to the power n u of minus n minus 1. This sequence is a left-sided sequence. And what is the ROC? ROC is mod Z less than something, some constant. Means this time what is the ROC? ROC is interior to the circle. And in the third case, when our sequence is both-sided sequence, what is the ROC? ROC is lying between two constants, half and 2. So in this case, the ROC is what? It is a annular ring. So what conclusion we have made? What is the ROC for right-sided sequence? What is the ROC for left-sided sequence? And what is the ROC for both-sided sequence? ROCs of infinite duration sequences. So I am writing the important central conclusion. Number one conclusion. For right-sided sequence, what will be the shape of ROC for right-sided sequence? ROC would be mod Z greater than some constant. Let's say that constant is R2, or you can say R is greater than R2. So it is exterior of circle. So if sequence is right-sided infinite duration sequence, ROC would be exterior of a circle. For left-sided sequence, ROC would be mod Z less than some constant R1, or you can say R is less than R1. So this time ROC is what? Interior to a circle. Which circle? Circle of radius R1. And if the sequence is both-sided infinite duration sequence, for both-sided ROC would be mod Z lying between two constants, let's say R1 and R2. So it is an annular ring. And number 4, for finite duration sequence, not infinite duration sequence. We have already seen this fact for finite duration sequence. What would be the ROC? Just remember my very first lecture on the Z transform. What was the conclusion? For finite duration sequences, ROC would be entire Z plane except possible exclusion of R equals 0 or R tending to infinity, or both R equals to 0 and R tending to infinity. And fifth point, which is also important, which sequence has entire Z plane as ROC without this exclusion of R equals 0 and R equals infinity? Only unit impulse delta n. only delta n Z transform has ROC as entire Z plane. So these are the 5 important conclusions regarding ROC. With this, I stop here. Thank you very much for watching my videos.